Ladies and gentlemen, hello and welcome back once again to the Operational Intelligence Market Overview here at InsideAnalysis.com. My name is Eric Cavanaugh with the Bloor Group, and today we're going to be hearing about a very interesting technology called the Starview Enterprise Platform from Starview, Inc. We're going to be hearing from Kevin Corey, who's going to walk us through what those guys have going on. So, Kevin, with that, I'll turn it over to you and show us what you got.
Fantastic. Thank you. Well, what we'll be walking through today is a demonstration of our platform, and I'll be showing several screens related to the platform, starting off with on our management console. The Starview Enterprise Platform is a self-contained enterprise solution that includes security integration, operational management of the platform, the environment to run what we call active models, as well as the environment to actually develop and deploy our active models. So to start off, I'll just give a quick introduction to the management console that we use to control the running environment. The screen that I have up now is actually a copy of our running management console. This actually shows an environment where I have 3 active models deployed. An active model is a term that we use to describe a solution that represents a real-time business model of events running on a server, capturing activities and doing analytics and potentially displaying those analytic updates to a web page, or sending those events to another monitoring system, or actually doing things like sending emails or pages for triggered alerts. So this screen is a screen that an operations person would use to manage an active model server. You can look at things such as configurations around server events, typical operating environment things, activities, CPU usage, and those kind of activities. So I'm going to move past this now. I just want to give a quick introduction to the management console. The real interesting part of our solution is actually the development environment. Because of the complexity of the solutions that we work to solve, we actually have developed a development environment for constructing active models. Now, I should be showing a couple of examples of that today. One that focuses on the ability to do simulation, and then one that focuses on a high-performance transactional environment. So what you see is a copy of the Enterprise Platform IDE in front of you. And I'll quickly explain some of the key components of this without getting into too much complexity. But as we talked about, our foundational strategy is focused on the active model. And what that active model implies is transactions actually moving through the system in near real time. So when you look at a model, what you'll typically see is a number of components of the model wired together with communications channels that represent the actual flow of transactions through the model. So the 2 types of communication ports that we have are request and respond ports. And this model shows, you'll see the orange box, you'll see in this case, we've actually got a port sending data out to a fraud UI demonstration or a fraud UI component. The different colored boxes represent different business processing logic. You can actually embed models within models. So if I, for example, double-click on that, it takes me into a subset model, which is a credit card transaction receiver that basically collects credit card transactions. It then feeds those transactions to a fraud user interface demonstration, or fraud user interface management console, as well as a merchant evaluation model, a credit card model, and a user model. So we have a number of different models on the display here that when we run this, will actually evaluate activity from credit card transactions, compare them to relevant information for merchants, relevant information for credit card, active credit cards, as well as users, and identify potential risk. Send those updates to the fraud user interface, which then gets displayed on a web page. So as I said, our infrastructure is such that it's fully self-contained. So we include our own web server, as well as a number of other components. When you're building a model, we provide a set of libraries that you can use for the purposes of constructing your model. To the right-hand side of the screen, you'll see a list of some of those components. We also have a library repository that you can connect to and download additional libraries as needed. And we also provide the ability to develop your own internal libraries. So if you have a specific business need that perhaps a library component doesn't already exist to support, you can have a development team internally develop that library component and then distribute it to the analysts or to the development team as needed. So it's a fully extensible model that allows you to really have full control over a distributed development structure. Okay. So with that being said, I'm going to go ahead and actually run this demonstration. I'm going to go ahead and just choose Run and run the application model. And what it's going to do is it's actually going to start up a development copy of an active model server. It's going to do a validation and compilation of all of the components, and I should have mentioned as well, we do provide access to developing custom logic using either Java or an internally defined language called Star. So it's going to compile all of that, validate all of that, and actually deploy that out to the development server that's running locally. And you'll see here the console is actually starting up, and it's validating all the ports are connected properly, doing all of its configuration testing. And then what it's going to do is, we'll see in just a moment, we'll see it bring up a web server, and that web server will actually start producing output that we can begin to monitor. So in just one moment here, we'll get going. So still reading transactions in. All right. So on this web server, I'm running this web server on port 8085 on my local machine. So I'm going to go ahead and switch over to that local machine at port 8085, and I'm going to start this model. So what I'm doing now is I'm actually monitoring what's going on as it's evaluating transactions coming in through the credit card data feed and looking for behaviors that will either indicate an over credit limit or a possible fraud. Possible fraud, for example, some of the cases that we have tested are if the geographic location of two transactions are such that it's unlikely an individual could actually be in those two locations to do that. Those are indicated by red boxes. The black boxes indicate where something comes in and it's actually over the credit limit. One quick note, this model is actually running on my laptop at about 50,000 transactions per second. So obviously, in order to achieve the kind of performance that we need to run in near real time, we need to be able to handle very high throughput. So we've put a lot of focus on optimizing transaction throughput, and to the point that I can actually run something on a reasonably sized desktop computer at nearly 50,000 transactions per second.
And I've seen a couple times the transactions per second will dip down between the 30 and 40,000 range, and I'm guessing that as we look at these little nodes going across from right to left, I'm guessing you can dig in deeper and understand why it was that the transactions per second dropped?
Absolutely. Typically what's happening is there's a fairly complex series of business validations that occur, and what can happen is a certain event can generate a more complex analysis to run for that particular transaction.
Sure.
So actually what's going on here is within the logic of how it's evaluating these credit processes, the flow of events changes pretty dramatically, and that typically results in the variation in the transaction throughput. Okay. So this demonstration just shows, primarily shows the throughput capabilities, and again, going back to the model, I'm not going to walk through the details, but what's happening is transactions are coming in through this credit card processor. They're being evaluated against some merchant criteria. They're being evaluated based on some credit card criteria and evaluated based on some user criteria. If, in fact, something turns out to be a potential fraud, it then sends a notification to the this fraud management console for potential action. Okay. Fairly in our functional kind of implementation models is actually a fairly straightforward model and a fairly simple model. But it does kind of show, one of the reasons we like to walk through this is it does give you a sense of the kind of throughput that we expect to get in most of our processing models. Now, obviously, as you increase the complexity of the analytics and the events that occur to manage that, the throughput can be affected. So we also support the ability to set up multiple models that run in parallel and communicate to a number of communications data sources. So we support Java messaging services, so queuing technology. We have our own built-in proxy interface, so you can actually connect multiple models through a high-performance proxy interface. We support things like database access and file access, and we also support web services as some of the basic communication components.
So how long would an implementation take? Let's say maybe it's a mid-sized bank or something, and they are curious about fraud detection and the exact things that you're talking about. If the trigger was pulled and they want you to come in, what's an estimated development time frame and maintenance and so forth?
It's a very good question. So building the base model, the real effort is in developing any customized business rules that they might want to deploy. If it's a matter of simply connecting to some existing data sources, building out a management console or building out some alert interfaces, and doing some basic analysis, we've got a couple of categorization components that we have for random forest categorization. We've got an anomaly detection engine. Typically, an implementation is about 2 to 3 months to get through the business process of identifying the business rules you want to monitor, collecting some data, running that data through the business rules engine, validating it, and then getting it deployed into a production environment.
Gotcha. And what if someone has been using some other off-the-shelf tool? I mean, a couple big company names come to mind in terms of doing this type of fraud detection. Is there a way that they can reuse the business rules they've already made, or would those have to be decomposed and recompiled, or how would that work?
So it's a very good point. So we rely heavily on machine learning-based algorithms for our rule generation. Certainly, if they wanted to simply recode those rules in our platform, we find the translation process to be fairly straightforward, and it wouldn't be a significant effort. But in most of our cases, what our customers want to do is they want to replace those handwritten rules with machine learning rules. And the exciting part about that is essentially I build the model, I run a sample set of data through that model, and that sample set of data becomes the baseline rule set that I can then validate against my traditional rules to confirm that, in fact, I'm capturing the same kind of events or oftentimes more events than I would have captured with manual rules. So I guess in summary, there's 2 ways of doing it. One is I can manually translate my existing rule set over to the Starview platform and get to a more real-time analytics evaluation of what's going on. But in most cases, the value is actually replacing those manual rule sets with our machine learning algorithms to automate the generation of those rules and the applicability of those rules to the real-time processing.
Sure. And I'm guessing as you detect actual cases of fraud and then validate that through some other process, you're able to feed that information back into the system to augment the nature of the rules and the types of data sets that are being examined and so forth?
That's correct. So what would normally happen is we'll feed those into a static repository of some type of database or some other repository, and then we will rerun the learning data set with those additional transactions in that learning data set, and that'll actually refine the rules process. So when you ask about how long it takes to deploy something like this, the actual construction can be fairly quick, but it might take several passes to capture adequate data to train the appropriate models to have a high-performance rules-based set. And oftentimes what will happen is you'll run that for a few months. You'll identify some additional things that you'll want to add to your base rule set, adjust your training data set, and then rerun those to create your new evaluation criteria.
Yeah, that makes sense. And I'm guessing there are also lots of other applications to this. I mean, I'm thinking of e-commerce, for example, and retail sites, especially if you've got various partners who collectively will sell and market products via the web. You guys could offer some value in there, I'm guessing, right?
Absolutely. So that's where we really put a lot of effort into building the developers environment to allow our customers to build whatever models they needed to solve their particular business process. So rather than trying to, encapsulate all of the complexity of a single problem into the application, our focus has been on building the tool set that allows developers, or allows a customer to build out their own models to meet their business needs. And I can give you another example. So we have another example of an application that we have. In this case, we focused heavily on the simulation process, and we really wanted to be able to, and the objective was, as I start this up, I'll explain what this model does. This model is actually used to evaluate the impact of electric vehicles on a grid. So a very different business problem, which is the customer wanted to understand what the impact would be as electric vehicles grow in a particular market space on their power grid. So in this case, we actually built a simulator that simulates the traffic of electric vehicles throughout the course of the day. It connects into their data set around all of their electric vehicle or electric load points and all of their transformer integration into the grid, and then actually simulates the impact of the load for a particular city as customers begin to move over to electric vehicles. So as you can imagine, very different problem than the problem that we have with fraud. I'll go ahead and start this up. And this is actually an example of that model. So you'll see here there's a map here. You'll see Berlin, so this is Germany. And what I'm going to do is I'm actually going to start this, and this is actually a simulation. So what this is going to do is when I hit run, it's going to call this component model that generates simulated traffic, and it's going to generate a number of events that get evaluated by the server model that's essentially comparing and determining load impact as the day progresses. So we hit run here, and you'll see this graph start to complete. And what it's doing is it's actually running a series of events over a course of a time for a 24-hour window. There we go. And then what it did is it actually ran a series of random events based on some models that they had depicted against the traffic patterns and their network of transformers in the city of Berlin to show the impact and the maximum network load throughout the course of a day. So in this case, it comes up with a predicted model that says your peak load impact is going to be at 7 p.m. and it's going to require 448 kilowatts per hour.
Wow.
Okay. So you can imagine I just demonstrated two completely different business problems using the same analytics capabilities, the same platform, and the same component libraries.
Yeah, that's impressive.
Okay.
What kind of person do you need to have in your organization? I mean, obviously you need developers, but what are some of the skill sets, and like where might you get someone who could step in and design something like what you're describing here? What does that person look like skill set-wise?
It's a really good question. To the extent that you so one nice thing about our architecture is that because we have a very componentized model, you can isolate the traditional kind of development skills to a very small subset. In fact, you can actually bring in third parties and say, I need you to build a component that does these particular things. And because it's so nicely encapsulated, as you can see by this model, for example, it's very clear what the input ports and output ports are, and they didn't explain this, but actually on each of these ports, we have the declaration of the message structure and the record layout for that particular interface. So a typical team is made up of a couple of more seasoned traditional IT software developers who are building individual components. And then you've got some analysts who are wiring together those transactions into a model that meets the business need and are developing some of the more advanced business rules, either using Java or using our star language or using some other technologies to build those things out. So the team structure is often a combination of business analysts, more advanced industry engineers. So depending on what industry you're in, the skills change, but clearly having a deep understanding of the industry is very important. And then the development process is really focused on building any unique components that don't already exist in the repository. And what we found is once you build a particular component for a particular problem, so I'll give you an example of that in this demonstration that I just provided regarding. So there's a component that is basically the interfaces with the actual transformer data, and it knows how a transformer behaves and is able to respond and interact in the model as would a transformer as you're plugging into the real-world environment. So there's some development, but a lot of it is as you build components, those components fit into your repository, and most of the work is actually the business analysis of wiring together the model to generate the appropriate learning data sets and the appropriate rules to run the results.
Mm-hmm. Yeah, that's really interesting stuff. That's great. And you have all these different, you basically already pre-packaged all the different kinds of systems and messaging and various things, and I'm guessing you can also, if some new one comes along, you can accommodate that as well with just a bit of programming?
That's correct. So as I mentioned, one of the things we're really focused on is the ability to build your own component libraries. So as new needs come up, so you've got a need to integrate with something that either we haven't currently built a component for. You can simply create your own library component as a project, compile it, test it, do all the work that you would do to build a component, and then deploy it out to your organization. So a lot of our team we're constantly evaluating the market, identifying new components to add to our tool set. But oftentimes customers, and especially where you've got perhaps a unique application, a homegrown application that you want to interface with, not something that we would actually have a component for, but the customer can build a component to interface with that custom application. Once that component's built, again, they can deliver to their analyst team, and they can begin to use that as part of their repository of resources.
Mm-hmm. Yeah, that's great stuff. All right. Any other questions out there? I think that this is very interesting stuff. Who do you guys typically compete with? I mean, it's like you've got characteristics of CEP in here, but you have a much more robust management environment, it seems to me, that fits into that real-time operational intelligence picture. I'm guessing that's why you're focusing on OI as opposed to CEP, right?
Absolutely. So I don't know, Angus, if you want to jump in and provide some thoughts on that. But one of the challenges that we often have is when working with customers, they'll evaluate us against kind of a CEP engine or also ETL space, right? So because we have so much activity around transforming data as it's flying in real time through the environment, it can oftentimes look kind of like an ETL platform. Or the other one is a business intelligence tool, because I'm actually taking this analytics, presenting it on a dashboard for some action. So it's kind of the combination of a CEP, a BI, and an ETL tool all rolled into one.
Absolutely. I think that's a well-made point, right? Because if you will, there's on one axis there's the how fast can you go, the high-speed sort of streaming type of products that exist in the marketplace, and we'll bump into them occasionally. But oftentimes it's really the analytics sort of plays, whether it's as part of a BI sort of market segment, there's the analytics plays, and customers will be looking for how do I take this high volume, high variety, high velocity data and apply analytics to it to help me make better decisions as part of my business process. And those analytics plays typically look at static data, where we're the guys who are doing data in motion.
Well, in very complex scenarios with unwieldy systems and difficult business problems, I mean, traditional BI is pretty cut and dried when you get right down to it. You're looking at numbers and averages and patterns and so forth, but you guys are actually harnessing highly complex real-time data flows and focusing on very specific business needs that revolve around those. I think that's how I would describe it. What do you think? Sounds good. All right, folks. Well, we've been taking a very interesting overview here of the Starview platform from Starview Inc. and Kevin Corey. Thank you so much for your time. You've been participating in yet another operational intelligence Market Overview Demo here at InsideAnalysis.com. Thanks a lot, folks. Take care. Bye-bye.